Hi and welcome to this video. In this video we are covering thunderstorms. And specifically we're working our way through the different types of hazards associated with thunderstorms. In this video we're going to cover icing, hail, and low ceiling and low visibility. So first we'll start out with icing, and you know the requirements for structural ice. For structural ice you need temperatures colder than zero and liquid water. That's what we call supercooled liquid water. And supercooled liquid water exists in cloud, and the amount of liquid water usually depends upon the temperature. If you recall from our icing discussions, we said that at temperatures colder than -20, there's a lot of ice nuclei that initiate the freezing process. But at temperatures 0 to -10, there's copious amounts of liquid water. And someplace in between -10 to -20, there's kind of a mix of liquid water and ice crystals. Of course, in cumulus clouds, the liquid water content is 3 to 4 times more than what you find in stratus clouds. And of course, the stronger updrafts in cumulus clouds result in moisture or liquid water being lofted to high altitudes, sometimes even to temperatures colder than -20. And of course, you've got the coalescence process going on, so the drops tend to be big. So these are SLDs. So where do you find ice? Well, you find it, of course, above the freezing level. And during the summertime, the freezing level tends to be anywhere from 10,000 to 16,000 feet. Now, this graphic is not the summertime. This is April. But it shows that even this time of year, across regions of Texas, you got freezing levels that are up in the 13 to 15,000 foot range. Across the central U.S., you're looking at 7 to 9. And this time of year, they're getting quite a few thunderstorms across Texas, Oklahoma, and the southern plains states. So, characteristics of icing and cumulus clouds: of course, you've got large amounts of liquid water, big drops, so that tends to produce glaze ice. Usually there's so much liquid water, even at cold temperatures, that you'll get glaze or clear type of ice. And of course, punching through clouds with high liquid water contents, you're going to get a severe rate of accumulation. So the icing tends to be quite intense when you're flying through cumulus clouds, punching through Qs. So you try and avoid punching through cumulus clouds, particularly at temperatures between 0 to -15. If you do fly through cumulus clouds at these altitudes, you'll get, in a short period of time, probably 30 seconds, you may be coated with an inch of ice. And that's not necessarily bad, because you can descend below the freezing level and get rid of the ice if need be. But of course, you got to coordinate with air traffic control, and sometimes air traffic control needs to be prodded and reminded that you need to descend to get rid of the ice. Another hazard associated with thunderstorms is hail. It's pretty obvious that hail comes from thunderstorms. And of course, hail is big balls of ice that fall out of thunderstorms. The requirements for hail: you need a very strong updraft to support those large hailstones. High liquid water content to accrete on small ice crystals to get it to grow to larger and larger sizes. And of course, big drops because they have very high collection efficiency. And then a tall storm, a very tall storm, provides you a very deep layer for the growth of hailstones. There is really no sure way of finding hail in storms except for flying in a storm and looking at it. You want to try and avoid that if you can. But One of the tried and tested methods over the years that seems to work pretty well is that if you have a very strong radar return well above the freezing level. So we said the freezing level typically during the summertime is anywhere from 10 to 16,000 feet. So if you are looking at red, if you see a really strong radar return anywhere from 20 to 26,000 feet, 30,000 feet, you know that storm is a hailer. So when you see really strong returns well above the freezing level, that indicates that there's ice coated with water, and also that there's a strong updraft that's able to support that to high altitude. So hail production typically between 0 and -20, so keep that in mind when you're looking at the winds aloft forecast or upper level charts, or even for that matter a sounding. There's some signatures in a thunderstorm that usually indicates that it is producing hail. And another one of these signatures is a weak echo region, or they also call it the echo-free vault. This is a region where the updraft is so strong and so fast that precipitation doesn't have time to grow to sizes that can reflect radar energy. And as a result, you get kind of an area where there's not very strong radar returns. We'll look at that in a little bit. You tend to see that with multi-cell storms. Also, you tend to see it with supercell storms. But pulse-type storms can produce hail. We talked about that in the thunderstorm classification. Also, multi-cells, squall lines, and supercells tend to produce hail. Here's your pulse-type storm. We said that, of course, with a pulse-type storm, the updraft, the single-cell thunderstorm tends to be, the updraft tends to be really strong. In a pulse, it's able to support the hail, and then it just cascades out. So that can produce a hail at the surface and also strong winds at the surface. As far as a multi-cell cluster-type storm, this is where of course, you have many cells in different stages of development. And the weak echo region usually is found in the mature storm. As it transitions from the cumulus to the mature, you can see that the updraft produces a region where there's weaker returns. Aloft, higher aloft, there are stronger radar returns, and eventually those produce hail. And then the multi-cell line, multi-cell squall line, of course, is a prolific hail producer just because it has such a strong updraft. Typically, you'll find overshooting tops, and wherever you have overshooting tops and a strong updraft, you usually can find hail also. And then finally, the supercell has a weak echo region that is kind of encapsulated or bounded by stronger radar returns. So we call that the bounded weak echo region, or the BWER. Where do you find hail? Typically, you find hail where there's thunderstorms, big thunderstorms. You find severe hail where you tend to have supercells. But this is a graphic that shows you the locations that typically get hail. Notice that it's downwind of mountainous areas or even in mountainous areas, and that's because typically the freezing level is much closer to the ground, so the hail doesn't have a chance to melt on its way down. But here's large hail, and large hail is typically where you find supercells. This was done for hailstones larger than 3/4 of an inch in diameter. This is before they changed. The climatology was done before they changed the classification of a severe thunderstorm. And then, of course, close to the updraft, that's where you find the biggest hail. As you get farther away from the strongest updraft, you will find smaller and smaller hail. Small hail may even be lofted into the anvil and may fall out of the anvil. Here's some hail damage pictures. Hail as small as it says there, 1/4 of an inch in diameter, is hazardous to the aircraft. In other words, small hail like that can usually chip away paint. Bigger hail produces bigger dents. You can see a picture there of a Piper or Twin Comanche that took a hailstone through the windshield. Produces substantial damage. Airliners are not immune to hail damage, and you can see hail produces quite a bit of damage to the engine inlet, to the turbine engine turbine blades, and also to the compressor blades as well, but also to the radome. Radomes are made of fiberglass. They tend to disintegrate when pounded by hail. So these are pictures from airliners.net. Back in back in 2015, there was a Delta A320 that flew between two thunderstorms, and the thunderstorms actually were growing together, and they experienced severe hail, and you can see the hail damage to the aircraft. I have some information on that under resources, the resources tab at EasyLMS if you go to EasyLMS. And the last thing we'll talk about in this video is low ceiling and low visibility. We talked about how when there's lots of moisture in the atmosphere, the cumulus cloud bases tend to be lower, whereas out in drier climates, you tend to have higher cumulus cloud bases. Of course, as precipitation falls, it saturates the atmosphere in the lowest layers, so you can have the formation of low ceilings and low visibilities in a short period of time. After precipitation starts falling, you'll find that that commonly happens in areas that are very humid, such as Florida and the Gulf Coast. So fog can happen very quickly. The onset will be as soon as the precipitation starts falling. So that's a problem. And then, of course, with strong winds near the ground can loft dust and can reduce visibility significantly also. And you'll typically find that with gust fronts. So those are some of the hazards associated with thunderstorms. In future videos, we'll talk about lightning and also convective wind shear.